starting to look like a little bit of alphabet soup, isn't it, eh? A's and K's and D's and W's, but we're just going to treat it like we would any other kind of adding fraction type problem. In order to add fractions or subtract them, we really need to get a common denominator. So as I look at the numbers in the denominators here, I see a 2 on the left and an 8 on the right. So I'm missing a 4. So I'm going to put a 4 down here in the bottom because 4 times 2 is 8. But if I do that, I need to make sure to simultaneously do it to the top also, because I can't just change fractions unless I do to the top what I do to the bottom. Remember, that's like multiplying by 1 like we talked about in class. Okay, on the left I also see an a cubed, but I see no a's at all on the right hand side. So over here on the right I'm going to insert an a cubed, again top and bottom. On the left I see a k. On the right I see k, but I see k squared. So I'm going to need an additional copy of k over here, top and bottom, so that way I can get that k squared. And then looking over at the right hand side, I do see one more thing I have to put in. There's a d cubed over here on the right that isn't located on the left. So I'm going to have to put a d cubed over here on the left hand side. So there's a d cubed and a d cubed. Okay, the nice thing is though, if you take that time and really be patient with these, then I can do the next step in one step and we'd be done with the problem. In the bottom we see a 4 and a 2. A 4 times 2 is 8. We see an a cubed in both cases. We see k and k, so we have k squared, and then we see a d cubed. So these are the least common multiple of those bottoms down, the least common denominator. On the top, let's see, for the left portion we have 5 times 4, which is 20, no a's, d to the 6, because I got d cubed and d cubed, k, and w cubed. I'm choosing to put these ones in alphabetical order. I don't know why I didn't do that in the bottom. But on the right we have a 3, we have a u squared, and then we have the a cubed, and they're separated by the minus sign. So that would be the final answer to this combined expression. So lots of details, not terribly long, but there's a lot of places to make accidental errors. So why don't you try one on your own here. Try to add these two rational expressions. And assuming you paused the video and gave it a shot here, notice this time the left has an 8 and the right has a 2. So I need to insert a 4 on top and bottom on the right, so that way I get 8. The left has a c, the right does not, so I'll put a c top and bottom. The left has k cubed, the right only has k, so I'll have to put in 2 extra copies of k, so there's a k squared. And then on the right there is a b squared that isn't located on the left, so I'll have to put that over here. So, taking all that time, looking at it carefully, the bottom should now have a 4 and a 2, which is an 8. It has 2 copies of b, 1 copy of c, and a total of 3 copies of k. In the numerator, we see on the left b squared, w cubed, and on the right we see 4 times 5, which is 20, c cubed and c for a total of c to the 4th, k squared, and then the original y squared. And these are being separated by a plus sign. So there's your final answer in this case.